Hello everyone, in this video we are going to discuss a new type of function which is called composite function. So let's check how the composite function looks like and how can we use it to do some practice. Before we introduce the composite function definition, let's quickly discuss laundry. I know everyone here probably has laundry experience at home. So basically, briefly to discuss laundry, basically we have dirty clothes, then we wash dirty clothes. After that, we put in the dryer, we dry them. So as you can see, if you consider the function, this is actually our initial input, right? And after the first function, washing part, now we have wet, clean clothes. And after that, then we have a second function, we dry them. So now I have dry, clean clothes. As you can see, the initial input is now checked. A new output, this is actually considered composite function. Simple words, composite function is multiple functions working on the same input. And in this process, we might have output in the process, let's say this. After the washing, we have output number 1 as wet, clean clothes. But this output number 1 becomes our new input for the drying function. So now I have finally a complete output, which is dry, clean clothes. So this process, you can see multiple functions working on the same input. This process is called composite function. But how do we actually write it and how do we use them? Let's see this. Composite functions sometimes, different times sometimes we call them composing function, or sometimes we even call composition function, or composition function, or function composition, different names, but they all named meaning the same thing. Multiple functions working on the same input. And notation-wise, we do have, since this is multiple functions, so it's like multiple layers of the function. We have here, we call f of g of x. The x is the input, like dirty clothes. And sometimes we can even put like this one. This little circle meaning here is a composition between functions. Be careful, this is not same as this one, because this notation meaning multiplication, meaning times. We time the function. So this one is different from this one. And sometimes you can even see people just put a parenthesis like that. Really no difference here, because both notation here same as f of g of x. And that's it. So now we are going to see some different kind of functions to see how do we find the value. The major part of this lesson is to evaluate composite functions. What does that mean? Now let's see the functions. We do have two functions. The first one is linear function, is x minus 4. So whatever the input we have here, we minus 4. The second one is quadratic function x squared. So whatever input, we square the input. Now let's check. We are going to find the three values here. The first one, f of g of 2. So to start, I want to remind you, just like, we figure out what is your dirty clothes, what is your first function you need to start. So we always start from the inside. So since the inside part is g of 2, so I'm going to use this to find a value. G is the name of function, meaning we are going to choose the g of x. This here is x squared, meaning input square. So the input is 2, so 2 squared is 4. Now, since I already know the value of g of 2, which is now is wet, clean clothes. So it's the first output. Then this 4 here is going to be my new input because g of 2 already figured out the value, which is 4. So basically, I replace g of 2, which is 4, because this is the value of that. And now I just need to figure out what is f of 4. Then what is f of 4? F is the name of function, so I'm going to use this one. So input minus 4 is a function. I just follow this. 4 minus 4 equal to 0. And that's it. That's our final answer. Okay, now let's try the second one so we have a better idea. So second one, as you can see, sometimes we can even put a parenthesis around it, but it's the same thing because we can rewrite them as g of f of 2. Again, we always start from the inside. So we figure out what is f of 2. F of 2 meaning this function, because the name of function is f, if we use this one, the input is 2, so 2 minus 4 is negative 2. Again, original question asking us find g of f of 2. So all we need to do, we replace f of 2 is 2 because that's a value of that function right now. So then what is g of 2? Again, since we're working on the function g, so all we need to do, replace the input into this function, which is x squared. So x is 2, it's going to be 2 squared, which is 4. So this is our final answer for the second one. Now let's move on to the last one. So last one, some student might be a little bit confusing, like, what is this? It seems f of f. Yes, it's like the same function working again. So it's like you wash the clothes, but you feel like it's not so clean, so you wash it again. You know, so it's like that. But again, the rule is now changing. We always start from the inside, so we figure out f of -1. Again, this is going to be the function f of x, so the input -4 is a function. The input is -1, so it's -1 minus 4 is -5. Next, we are going to work on the original question with f of -1. Again, now since f of -1 is -5, so I just put a -5 here. And then again, we're still working on the function of f, so we just go back to check here. X minus 4 is a function, so x is -5. I just replace this. Then the final answer is -9. So this is our final answer. Okay, that's how do we use composite function and use a function to find the value of the composite function. This process, as we mentioned before, we always start from the inside part and then we just go to the out layers, like multiple functions. We just figure out what's the first one, what's the next one, which function we use, how do we substitute the input, go to the function to find out the new value, and that's it. I hope this video is helpful. Thank you so much for watching. See you soon, everyone.